Assalamu alaikum. Bismillahirrahmanirrahim. So, in the previous class, we talked about physical quantities and units. We discussed different physical quantities and their types like scalars, vectors, base quantities, derived quantities. We did some examples of each one of them and we did past paper questions on them. Then we talked about prefixes, and then we discussed how to write a physical quantity with its unit and magnitude, and lastly we talked about significant figures. So today we are going to move a step ahead and we are going to discuss base units of all the physical quantities. We should be able to express and write every physical quantity that exists in terms of its base units. And we already know that there are only 7 base quantities and their respective 7 base units, which are as follows. The quantities are length, time, mass, temperature, current, and their respective units are length in meters, time in seconds, mass in kilograms, temperature in kelvins, and current in amperes. Now their respective symbols for the physical quantities are length, it's L or D, time it's T, mass it's M, temperature it's T, and current it's I. Similarly, the symbolic representation of these units for these base quantities are meters, we represent it with M, seconds it's S, kilograms it's kg, kelvins it's K, and amperes it's A. So we should be able to write each and every physical quantities in terms of these 5 base units. That's meters, seconds, kilograms, kelvins, amperes. We should have nothing other than meters, seconds, kilograms, kelvins, amperes in our unit. If we are able to do that, that means we have successfully written base units for our physical quantity. Okay, so there are some derived quantities which I would list down, and they include speed, acceleration, pressure, work, force, power, electrical charge, potential difference, electrical resistance, specific heat capacity, and then frequency. Now we should know the units for each one of them. The unit for speed is meter per second. Acceleration, it's meter per second square. Pressure, it's kg per meter per second square. Its other unit is pascals, but the base unit is kg per meter per second square. For work, its unit is joules, but the base unit is what? Kg meter square per second square. For force, the unit is newtons, but its base unit is kg meter per second square. For power, its unit is watts, but its base unit is kg meter square per second cube. Electrical charge, the unit is coulombs, but the base unit is ampere seconds. For potential difference, its unit is volts, but its base unit is kg per meter square per second cube per ampere. For electrical resistance, the unit is ohms, but its base unit is kg per meter square per second cube per ampere squared. For specific heat capacity, its unit is joules per kg per Kelvin, but its base unit is meter square per second square per Kelvin. And for frequency, its unit is hertz, but its base unit is second power minus 1. Now, these were all the base units that we have seen, and you can very clearly identify that all these 7 base units, base units, they include a combination of these 5 base units. There's nothing more than this. every physical quantity has something from these 5 base units, right? So now we'll prove that actually these are the base units, actually they exist. How? Look here, we have speed as meter per second, acceleration, its base unit is meter per second square, you know the unit of force. Alright, so I have written all those base units along with the physical quantities, and now we are going to discuss each one by one. We know speed is distance upon time, distance is meter and time is seconds, so it becomes meter upon second, that is ms minus 1, hence proved. Then we know acceleration is velocity upon time or speed upon time. Velocity is meter per second upon second, meter per second, and time is second, so my unit becomes meter per second upon second. Second goes in the numerator and it becomes minus 1, so it's ms minus 2, meter per second square. Force, it's kg meter per second square, and its formula is F equals ma. M is kg, and acceleration we have just found the unit. What is it? It's meter per second square. So meter per second square makes it kg meter per second square. Hence proved once again. Right, so then pressure. What is pressure? Pressure is force upon area. Pressure is force upon area. What is force? We have just found its unit, kg meter per second square. Kg meter per second square, this is force. What is area? Area is meter per second square. Meter per second square. Combining that, meter square goes in the numerator, become m minus 2. M is already present there, so m and m minus 2 makes it m minus 1. Hence, it will become kg m minus 1 minus s minus 2, again proved. Then you have work. What is work? Work is force into distance. Work is force into distance. We already know the unit of force, that's kg meter per second square. Kg meter per second square force, right? And then distance is meters, so meter into meter, it makes it meter square. Proved once again. Then you have power. What is power? Power is work done upon time. And you know what is work done? It's kg m2 s minus 2. Kg m2 s minus 2, right? Kg m2 s minus 2. And what is time? Time, it's seconds. So second goes in the numerator and makes it what? Makes it s minus 1. S minus 2 is already present there, so s minus 2, s minus 1 makes it s minus 3. S minus 3, right? So again you see it's proved. Then electrical charge, it's current into time. Charge is equals to current into time, right? Charge is current into time. So current is what? Current is amperes. Current is amperes. And time is what? Time is seconds. So proved once again. Then potential difference, it's what? Potential difference is work done per unit charge. What is potential difference? It's work done per unit charge. And now what is work done? We have already found its unit. What is it? It's kg m2 s minus 2, right? And now I'll put that over here, kg m2 s minus 2. What is the unit of charge? I just found it over here. It's ampere seconds. It's ampere seconds, so I place ampere seconds now. And now second goes in the numerator, it becomes s minus 1, s minus 2, s minus 1. Make it s minus 3. Amperes goes in the top, it becomes a minus 1. Right? So again it's proved. Right, then electrical resistance is what? It's voltage over current. It's potential difference over current. Resistance is potential difference over current. And we know, we have already worked out the unit for potential difference. What is it? It's kg m2 s minus 2. Kg m2 s minus 2. Kg m2 s minus 3 and ampere minus 1. Right, that's the unit of potential difference. We know the unit of current. What is it? Unit of current is amperes. It's amperes. So amperes goes in the numerator, becomes a minus 1. So a minus 1, a minus 1 makes it a minus 2. So my final unit becomes kg m2 s minus 3 a minus 2, right? So once again it's proved. Lastly, specific heat capacity. What is specific heat capacity? Specific heat capacity is basically charge upon q upon m delta theta, that is thermal energy upon mass into change in temperature, right? So thermal energy or any type of energy is basically the work done. And what's the unit of work done? The unit of work done is kg m2 s minus 2, and hence I place that unit over here, kg m2 s minus 2, right? Kg m2 s minus 2. What is the unit of mass? It's kg. What's the unit of mass? It's kg. And what's the unit of temperature? It's kelvins, right? Kelvins. And here I cut out kg with kg, and hence I get rid of this. So my final unit comes up to be s minus 2 m2 kelvins minus 1. Right? So again it's proved. Alright, and this k is minus 1. Okay.